Welcome to ADF Insider. In this session, we talk about best practices for integrating SOAP and REST services into Oracle ADF. My name is Frank Lymphius, and I'm from the Oracle JDeveloper and ADF product management team. When we talk about integrating services in Oracle ADF, then we talk about two different things here. One is to consume a remote service in an Oracle ADF application, and the other is to expose ADF business models as a service to remote services. So let's start with how to consume a service in your Oracle ADF application. And here again we have a choice. There are two types of services we can deal with. One is a more traditional and long on the market SOAP service, and then there is a newer RESTful service which also has its momentum and use cases, and for that reason we cover both of them. So let's start with the SOAP integration. Now the SOAP service integration, if you read this picture from left to right, shows that we have three options in Oracle ADF to access the data or the business logic on the remote server. The web service data control is a native data control that is declarative to use, and it's already in Oracle ADF. So from the new gallery you can go to the business services and then you find an entry for the web service data control, and at design time you point the web service data control wizard to the web service definition, which could be on a remote server or copied locally, and then it will create the data control so that at runtime the web service data control directly accesses the web service, queries the data, and makes it available in the Oracle ADF application. There are two more options on this picture. One is to access a web service from ADF Business Components, and the other is to use a Java Bean data control. Both of these options don't access the web service natively and direct. Instead, they use a JuxWS proxy client. You can generate a JuxWS proxy client from JDeveloper, again starting from the new gallery, and then pointing the wizard to the web service definition. The JuxWS proxy client is a Java object that generates representation objects of all of the entities being used within the web service. Though you could directly access the JuxWS proxy client from ADF Business Components or generate a Java Bean data control from it, our recommendation is not to do that and instead have a Java Bean wrapper up front, where the Java Bean wrapper acts as a kind of a domain object. The idea of the Java Bean wrapper is to filter the communication between the client and the service, but also, as it is considered to be a contract that you create between the web service implementation and the application developer that builds the ADF application, you can use that to translate non-meaningful names and methods used in the web service to more business-oriented meaningful names on the application development side. Another use case is to provide additional functionality, maybe filter functionality that is not directly available on the web service. So you can use the Java Bean wrapper for many things. You see that the Java Bean wrapper actually instantiates the JuxWS proxy client, and it doesn't extend it as you would expect from an object-oriented approach. The reason here is that, especially if you use it as a Java Bean data control, the JuxWS proxy client contains a lot of methods that you prefer to have as an internal implementation detail. These are methods that are not meaningful at all to the application developer. If you extended the Java Bean directly from the JuxWS proxy client, then the data control you generate out of this would list all of these methods that you don't want to show. For that reason, the Java Bean wrapper instantiates the JuxWS proxy client. One benefit you get from having a Java Bean wrapper sitting between the client and the server is that you can cache data that you query from the web service, so that you don't necessarily have to go back to the web service for all the queries that come from an ADF page. The cache could be as simple as a Java object cache, some object structure that you maintain in a POJO, or more sophisticated coherence or whatever caching strategy you can come up with. The idea is that after the initial query to data, you save the data in the cache, and the next time that the query comes from a page through the Java Bean data control or ADF Business Components, you will directly look into the cache to see if the data is available. And if the data is available, you read it from cache and not query it from the web service. If we look at the POJO data control, then we see that the POJO data control is generated from the Java Bean wrapper. And you do this in the Application Navigator in Oracle JDeveloper by selecting the Java Bean wrapper with the right mouse button and then choosing Create Data Control. Once you did this, you see the data control palette showing all the collections and the methods that are contained in the web service access and exposed through the Java Bean wrapper, so that the application developer now can drag and drop collections to the page and render them as forms or tables. For ADF Business Components, again, the access is through the Java Bean wrapper, but as you see, it's slightly different compared to the POJO data control, because there's no wizard that would allow you to declaratively step through the process of creating a web service access. What you do in ADF Business Components, you create programmatic view objects and a programmatic entity object. The entity object is needed if you want your web service to be updatable. So whenever you want that a form that you build based on the view object allows you to submit data and keep it in the local entity cache, you need to create an entity object. Then for the do.dml operations, so that you can write back updated information to the web service, you override methods on the entity object. And the same is what you do for the view object. The Fusion Developer Guide is very clear and detailed on how to do that for PL/SQL stored procedure access. If you look at that example, and if you change the implementation details, which in our example point to PL/SQL packages, and just replace these with calls to the web service through the Java Bean wrapper, then you get the idea of how to do it exactly. As an overview, on the entity there are two methods you override. Do.dml, which is always called when entities are updating, normally the database, but in this case the web service. So you will check if the operation is an insert, an update, and delete, and then call the equivalent method on the web service. For the view object, there are some more methods to override, which are all the methods that internally are used by ADF Business Components to provide the estimated row count and to prepare the query. So what are recommended practices? Well, first of all, the web service data control, as you've seen on the picture, is very simple. It doesn't allow you to intercept data or to work with data or to filter data or to prepare data. For that reason, this web service really is suitable for simple web services. So if you use the web service data control, that might be something you use with a weather report or with stock quotes, or any web service that doesn't come with complex payloads and nested objects and all this kind of stuff. If you have more complex services, then the recommendation is to go with the JuxWS proxy client and either the POJO data control or the ADF business component to access it. If your business model that you build the application with is ADF business components already, then it's very likely that you want to preserve the same API towards the application developer, and for that reason you will decide to use a web service data access through ADF business components. So you create a view object and an entity object and override the method we've seen before to access the web service. Well, ADF business components is not designed as a container for web service access. So if your business model doesn't use ADF business components, but if it's a SOA model or if you use POJOs or enterprise Java beans, then you might want to go with a POJO data control. The POJO data control also provides functionality that goes beyond of a simple access of a data source. It supports pagination, for example, which you cannot have by default in a web service, but if you go through the proxy client or the wrapper client, then this class can help you to implement pagination by just fetching data and caching the data, and then if the user scrolls, for instance, in a table, you only pick the data that is required and call this data then from the web service or from the cache. So our recommendation is, if your business model is not ADF business components but SOA or POJO, then go with the POJO data control. Representation state transfer is what's behind REST, which means that instead of sending down objects to the client for manipulation, you just send the representation of an object state. So that could be through XML, that could be a text object, it could be an image, or very popular, it could be JSON string. When you get back to a RESTful service, then the way you get back to the service determines what happens to data. So if I have a form that is displayed on my HTML page, and if I send it back as a post request or as a put request, then I update or create a new record. If I send it with a delete request, then the data gets deleted. So it's the HTTP method that really matters here, and that makes the difference between REST and the SOAP service. The standard in Java EE to deal with RESTful services is JUXRS. JUXRS is an XML API for RESTful services. The reference implementation is a library called Jersey that comes from open source and now became the reference implementation for JUXRS. In JDeveloper 12c, for instance, you will see that Jersey is bundled with Oracle JDeveloper. For 11g, to use JUXRS integration calls, you will have to get the Jersey libraries and configure that with your project. Again, if we look at the architecture that we have ready in Oracle ADF to work with RESTful services, we have three options. The Web Service Data Control obviously is not an option, because that is dealing with SOAP requests, but instead we can use the URL data control. In 11g release 1, this option is very limited, because all that we can do is we can send a GET request with the URL data control. Now if this hits a RESTful service implementation and it returns XML, then you can work with that. But as we are only dealing with GET requests in 11g release 1, there's no way for you to update the service. In 11g release 2, especially if you are on a later version like 11.123, we allow you to specify the URL data control for all kinds of HTTP methods. You can specify a URI for GET, for POST, for delete, and this now allows you to have the full CRUD operation against a remote service. The only requirement we have currently in the URL data control, and you might call it a restriction, which we're planning to lift for a later release, is that we need the payload to be XML. So once we get XML back, we can represent the XML in the data control palette for the developer to work with. The two other options are, as before, Java Bean data control and the ADF business components, and here, similar to the picture we had before, we used an intermediate object, which is the REST client, which is coming from Jersey. So you build a Jersey client to access the RESTful service, and then have a Java Bean wrapper to dispatch the communication of the POJO data control and the ADF business components. The way that you build the POJO data control and the connect ADF business components to the RESTful service is exactly the same as with JUXWS services. The only difference is that the REST access is through the proxy client, which comes from Jersey. So far we looked at how to consume a web service from ADF. Now we turn it around and look at how to expose an ADF business model as a service to other service clients like JUXWS proxy client. As before, we do have two choices here. One is to expose a model as a SOAP service, and the other is to expose it as a RESTful service. To expose a business model as a SOAP service, we can use Enterprise Java Beans and use annotations in them, or we can use ADF business components. For RESTful services, again, Enterprise Java Beans reference from annotated POJOs becomes an option, and in a future release of Oracle JDeveloper, we will have the ability to also expose ADF business components as RESTful services. So let's have a look at ADF business components SDO services first. So in a nutshell, what you do is you declaratively enable application modules to be accessed from Web Services Client, from SOA, like BPM or BPOL processors, or from other ADF business components applications, and that you create entities based on ADF business components SDO services. The service interface that you define on the application module exposes view objects, operations, custom methods, or view criteria on the service interface as methods or as data. Technically, what we create once you chose this definition is an EGB 3.0 annotated web service. But this is a technical implementation that actually is nothing that you would code for. So you would get this declaratively by choosing to expose an application module as an SDO service. This picture shows the architecture. On the left hand side, we start with framework extensions that we typically recommend you building for view object implementation classes, entity object implementation classes, and application module classes. Then, when creating the model, which most likely will be based on a database table, you create entity objects to be able to update the table. You create view objects to read from the tables, and then the application module to expose the business model. On the application module level, as I mentioned before, you have a declarative option to define which of your model, the view objects or the view criteria, you want to expose on the service interface. Same for client methods. And then technically we turn that into an EGB 3.0 session bean and annotate this so it becomes a web service and is discoverable. And then on the right hand side you see the various clients that can access this. So we have a web service client, SOA, and ADF Business Components entities. The best practices to share when you deploy SDO services based on ADF Business Components is to think SOA and think deployment and also think network. Keep in mind that the use of a service comes with limitations. One of the limitations is that because you're using SOAP services, the payload is expressed in XML, which comes with some overhead. So depending on the network connection you have, this might cause some delay. So think about tailoring the data that you send down to a device via a service to the absolute minimum of the required data. Think, for instance, ADF Mobile. If ADF Mobile accesses your ADF Business Components model data through a service, then you want to make sure you're not sending 100 million of data down to the ADF Mobile client, because that's for sure is not what the client could handle. So tailor the service and shape the data that you send down to the mobile device so that the mobile device can handle it. So this is very important to keep in mind when you build service implementations with ADF Business Components. Also, a recommendation is that if you have an ADF Business Components model that you use for web applications, to not use the same project to expose services. Instead, what you should do is you should have an ADF library that contains the common view objects, entity objects, and application modules, and then you build a separate service project and a separate web project. So these two basically will share the same data logic and will query the same data. They're not sharing a session, but they're sharing the same validation and the same business logic. But then this allows you to really tailor the project that exposes the services to the need of a particular client. So for RESTful services, here, at least for the time of recording, I will have to show my little safe harbor slide, which says that whatever I'm talking now about is what comes in the future. So you cannot buy it today, and you shouldn't sign any contract work based on the information you get here. However, to show you where we're going with the product, it's a very useful addition to this session, and this is why this ADF Insider session has a recording on ADF-BC RESTful services. So let's continue with that stream. So what we do here is pretty much the same as we do with SDO services. In a future release, which for sure will be JDeveloper 12c, but also might be some patch set if we decide to backport that functionality, you will have two options on an application module. One is for the already available SDO services, and the other one is for RESTful services. And for RESTful services, we aim for HTML clients, mobile clients, or enterprise applications that programmatically access the service to read the data in. Similar to SDO services, again, the REST interface is planned to expose view objects as a resource, probably view criteria as well, so that we have the same set of functionality available for RESTful services as we have for SDO services. The view objects are considered to be the resource, and those who work with RESTful services, you know that the resource actually is what is becoming part of the URL. So in our case, if you have a view object that is department's view and you want to expose this as RESTful service, then that will show as a noun in the URI that is called. And then based on the HTTP method setting, post, delete, put or get, the definition will be to read the view object, to write to the database table, for instance, or to delete a row. The payload that we provide with RESTful services and ADF business components is JSON. So this is a popular format, and right now there's no plan to have XML yet, but we don't know what comes in the future. So initially we come up with JSON formatted strings, and that is what we can work with on the client side. The architecture looks very similar to the architecture I showed for the SDO services. Again, framework extensions as we always recommend you to use, and then you create an entity object, a view object, and application module. As I showed during this talk, we have three options to implement SOAP or RESTful service integration. So the first is to use a Java client, access it through a wrapper bean that then you can use from ADF Business Components or Approach Data Control. You use this option for complex services. Services that have a complex payload, or services that you require to shape the data structure, that you want to intercept the data, that you want to cache the data, or you just want to translate the methods exposed on the web service to more meaningful name for the application developer to use. We do have two native implementations to access SOAP services and RESTful services. You can have a URL data control and just point it to a RESTful service, or you can use the web service data control and point it to a SOAP service. For the URL data control, recommendation is to use at least 11G release 2, as this supports a full request cycle, which is create, read, update, and delete for RESTful services. The idea behind being able to have ADF Business Components exposing its model as SDO services and RESTful services is that we want to give you the ability to just learn one skill to build models for all three areas of interest, which is web, SOA, and REST development. This concludes this ADF Insider session on service integration in Oracle ADF. Hope you enjoyed it, and hope to see you soon on ADF Insider.